Thank you so much. We're here with Andrew and Catherine from Field Ready, and we're so excited to dive in a little deeper to some of the details around the challenges we've developed with them. And I think it'll be useful just to get started with hopefully an easy question, which is, can you tell us a little bit more about Field Ready and the work you do and, you know, your organization's mission?
Thanks, and yeah, thank you very much for including Field Ready in these the Hackaday challenges here. Field Ready is a humanitarian disaster relief organization, which means that the kind of work we're doing is with people affected by disaster in refugee situations, working with refugees, say the Rohingya refugees in Bangladesh, or internally displaced people who might have been affected by, say, the recent tropical cyclone Harold, that has affected half the population of the Pacific island nation of Vanuatu. And there's a recovery process, a rebuilding process for those communities. Or longer term reconstruction, such as in Nepal, after the 2015 earthquakes, there was a response, but now 5 years on, there's more work to be done in terms of recovering the people's livelihoods still. And then in Iraq, after the conflict there, in particularly with ISIS occupation in the north of the country, trying to create jobs and help to create jobs for young people so that they can develop their own businesses, create their own enterprises, and those are the sort of humanitarian purposes that we work for. Our mission really is a little bit different to that. We're not the normal humanitarian organization, if there is such a thing. What we try to do is we try to manufacture aid supplies in the field. What we try to do is to use all of the capacities and the technologies, the ideas even of the maker movement, of digital fabrication, maker spaces, and we apply them into humanitarian relief contexts. So basically, Field Ready makes aid supplies in the field rather than shipping them in, rather than shipping in supplies to a disaster zone. And you can imagine, perhaps after an earthquake or a cyclone, a lot of the transport infrastructure has been destroyed. There's lots of problems with that. We try to make the supplies locally, and we're finding that can make the supplies cheaper, faster, and better in terms of when they're finally handed over to people who've been affected by the disaster. By making them locally, they can be cheaper, faster, and better, which means you can help more people more quickly, more effectively. And by using some of the ideas of the maker movement, you can also create local livelihoods and jobs and help with that recovery I talked about. Yeah, that's Field Ready's mission, to transform the way aid is supplied in the world.
Thank you. I think that's a really great foundation to get started talking about some of your current projects, and then we'll get into the challenges more specifically. So I know that there's a lot of stuff you guys are currently working on, some things that were definitely affected by recent events as well. So if you could just briefly explain some of your current work, and then we'll get into the first challenge.
Well, there are three kinds of work that we do. One is the response activities, and whether that's to tropical cyclones or to volcanoes or conflict or earthquakes, mobilizing to actually make supplies and provide them to affected people. The second thing that we do a lot of is capacity building and quality assurance almost. So trying to support local manufacturing companies, local maker spaces, local entrepreneurs and startups to help them make aid supplies, to help put us out of a job, and to make sure that some of those some of those communities can be more resilient and provide the aid that they need for themselves by themselves in future disaster responses. And then the third thing we do is we try to change the way that the humanitarian system is working. So there's quite a bit of activity to influence the aid sector to say, you know what, guys, making things in India or China or Turkey, warehousing them in Dubai or Copenhagen or Panama, and then shipping them to Fiji, to Bangladesh, to Somalia, whatever it might be, that's a bit of a crazy way of doing things. Why don't we find new ways of delivering aid, trying to transform the system? Something that might help some of the people involved in the challenges we're putting forward is that one of the ways we're trying to change the system is we have published a book. So I'm going to plug the book called Managing Humanitarian Innovation. And a lot of the information about the way that we work and some of the tools that we use to innovate in the middle of the disaster response and to work on humanitarian innovation more generally is included in this book. So over the course of the challenges in the coming weeks, we might be referring to some of the content in that.
Awesome. And Catherine, do you want to say a little bit about what you're currently working on in response to the COVID crisis? And
I guess I'd like to say, if I'm talking about what I'm doing isn't necessarily representative of like what, you know, everyone is doing at Field Ready. But yeah, I was supposed to be starting a position as a mechanical engineer with the Pacific team in Suva, Fiji on April 1st, but got stuck in the States. And since have been kind of splitting my time between helping coordinate between all our efforts globally on the technical side of things, and also managing some work that's happening here in the States. We've been running a partnership with an organization called COVID-19 Shields that started up in the wake of COVID out of a shuttered scenery fabrication facility in LA, led by a woman named Alex Pangiris. And so she's manufacturing and distributing thousands of shields a day, and we are helping her distribute donated and discounted shields to people who need them. So far, we've gotten some shields to 2 different hospitals on 2 different Native American tribal lands, and then we are going to get another large chunk to an organization that provides healthcare for homeless folks in kind of all over California, but mostly in San Francisco. And then we've had a sprinkling of other smaller donations to some people providing meals to unhoused folks and a harm reduction organization in Portland, Oregon, and another harm reduction organization in Porterville, California.
I think that's representative of, I mean, COVID-19 has come along in amongst all of these other disasters and responses that are taking place around the world. So we've been manufacturing PPE. We've been manufacturing face shields. We've been designing and manufacturing hand washing facilities, things like that, that, you know, actually everybody all over the world is suddenly needing. And they're finding that the traditional supply chains aren't supplying. So we're beginning to really ramp up the manufacture of those locally as part of COVID-19.
Right. No, that's great. I think that gives some good context for getting into the challenges. And like you've said, it's representative of how you guys need to respond in situations depending on what's happening and where it's happening, and, you know, where your people are and what you have available to you, and really taking advantage of the local resources and local connections there. So I think it's a great example to get us started. So first off, we're going to get into the one of the open call challenges, which is the fluid warmer. I think that it would be really helpful to just start with sort of, basic definition of what a fluid warmer is, what it does, and why it's important to the work that you all do in the field.
The fluid warmer, yeah. So a fluid warmer is a medical device that heats intravenous fluids up to body temperature prior to those fluids being injected into a patient. This is really important because if you inject a fluid that's colder than body temperature, you can give a patient severe hypothermia, and it can result in death. And by intravenous fluids, these are most commonly either human blood for a blood transfusion or IV saline for rehydration. And when there's not like a proper medical device fluid warmer, facilities will still warm the fluids, typically through imprecise methods like submerging the fluid, which is enclosed in like a plastic disposable, into like a warm water bath. And this is really dangerous for blood transfusions because if you heat whole blood a couple degrees too much, you'll hemolyze the blood. This means that the red blood cells rupture. And if you inject hemolyzed blood into a patient, that can also very easily kill a patient. So without access to proper fluid warmers, blood transfusions become very dangerous.
So in some of the documentation we were looking at as, we went back and forth developing this challenge, I remember heating time being something that was seemed to be an important factor, and then also something that we've noted in the challenges that we'd like it to be cost effective. So I was hoping we could dive in a little bit more to those two factors and explain, why effective solutions would take these things into account.
Yeah, heating time is really important. Typically the way a fluid warmer works is that you take the tube of the IV inlet line and wrap it around a heating element. So the warmer is never actually in contact with the fluid, it's in contact with a tube. And so from the tube entering your fluid warmer to the tube exiting your fluid warmer, you need to heat the fluid up to temperature. And medical facilities have standards for how quickly they will inject IV fluids. And so you just want to make sure that at the rate the fluid is passing through the tubing, that it gets to body temperature in time. So that's where heating time comes into play. Cost, yeah, that's important. I mean, the reason these facilities don't have fluid warmers to begin with is generally a lack of resources. So if we're making something on the ground, it has to be affordable and scalable. And to that point, also the design needs to be made out of like easily sourced parts, and it also needs to be designed such that if you find different parts in different locations, you can easily adapt the design or the code or the electronics to accommodate whatever components it is you're able to source if you're making these in the field. And one thing I'd say more important than any of the three things I just mentioned is safety. Field ready doesn't usually delve into medical devices that can kill a person. But a fluid warmer is a device that if it's poorly designed and the safety features aren't all the way there and it's not, not up to par, like it can kill a person, and that is unacceptable, obviously. So I'd say safety features should absolutely be at the foremost of anyone thinking about this.
One of Field Ready's interns developed or started to develop a fluid warmer, open source fluid warmer, I believe, and did a whole in-depth report on it, which we're gonna sort of summarize and make available to the community. And we just wanted to, I wanted to go over sort of on the call, what were some of the findings? I know that there were, there's a lot of great research in there that covers some of the things we just mentioned, the heat time, sort of the process of how it actually works and how to accomplish those things. And she also has some great case studies or sort of benchmark examples. But I know that there were also some feedback from field ready team members sort of in the field of how this could be improved. Were there any specific things you could highlight?
One of the lessons about what could be improved on the machine is on the blood warmer device is essentially the user aspect of it, to make it a lot more straightforward for the operators to use, because we would be introducing these into contexts where perhaps they haven't had them before, and they haven't used these sorts of devices, so they're not necessarily going to be very experienced on it. The training that might be available would probably often be a virtual training, and there isn't a great deal of ways to sort of experiment. One of the to practice rather than experiment, I think I should say, to practice on using the device before you use it on a real patient. So if there's any sort of feedback mechanisms that can be relied upon to help provide that training that can be built into the design of the product, that is probably worth paying the extra cost for.
From the work that has already been done, what's noted in that thesis of needing the most work, and definitely where the least work went into to start, is the electronic system and the Arduino controlling that. And that's really where all the safety features happen too. I think the code as is very messy and hard to follow. So I think a deeper dive at improving the electronic system. She clearly put a lot of time into the kind of mechanical design of how it all fits together, and I'm sure there's room for improvement there, but I think there's a lot of room for improvement in the electronics.
So the other open call challenges that we've developed with Field Ready are in the form of some sort of tools that could really come into play in the field, and also in some of the maker spaces. This grew out of conversation with some of the team members at a makerspace, and I'm really excited about these because I think they're gonna really be relatable for a lot of our community, and also I could see us wanting them at Design Lab, at all kinds of places. So I think these have a lot of legs. So the first one being a versatile heat sealer and welder, and then the other one being a UV cure wand. I know that there are some interesting examples you guys mentioned when we were developing these challenges that could currently be addressed with these sorts of tools. So I think that'd be a great place to start, just to cover. I know there was a sealing sanitary bags for equipment was one. And so maybe we can start with some of those examples and then get into more of where the inspiration for this challenge came.
Yeah, on the heat sealer front, some immediate thoughts for applications would be packaging. So kind of, we make items and we have to distribute them, and whether they're healthcare medical device items or items in other sectors, we want them to be clean when we distribute them. So kind of versatile heat sealer where, you can wrap something in plastic and get a seal without something that's quick and allows you to package something in a sterile way, is one really quick idea. I know also thinking about in the wake of COVID, we were looking at producing medical isolation gowns, and sewing can be slow if we're talking like makerspace scale production, not automated textile factory. Sewing each and every gown can be very slow. So we were kind of looking at some of the DIY stuff where people were basically using like hair straighteners to plastic weld. And so I think that it could be really useful to be able to weld soft plastics. We also have an intubation box that was developed in Fiji that it would be useful to have something like this for. And so something that's versatile, that has some adjustability to it, where you can dial it up if you're trying to seal and weld thick plastics, but if you're trying to use like a really thin plastic for packaging, you can dial it back, something that can allow you to not necessarily be doing it at a desktop, but standing up. Basically, like, we work with all sorts of different sizes and shapes and products and materials. So versatility is key. So this one is more of like a pie in the sky idea, not so much coming out of we would use this tomorrow if we had it. Whereas the heat sealer is very much we would use this tomorrow if we had it. But UV Cure is just a really powerful tool for prototyping and fabrication. It's commonly used in medical devices, aerospace, automotive, but it allows you to adhere a lot of different materials to each other. Some materials that are with traditional adhesives very hard to get to bond to each other, so like metal on plastic, for instance, and it allows you to have fluid tight bonds too, which can be really helpful in medical devices or kind of wash applications. Anytime you're moving fluid, basically, which is something we have an interest in sometimes.
I think that covers it. And I think that, again, we wanted to reiterate that user friendliness and safety and affordability will be crucial to all of these entries and to the proposed solutions in these spaces. I think, again, as you mentioned, this has to do with the variety of sort of applications, the people that might be using and implementing these methods or tools or devices, whether they're field-ready staff or they're people that are being trained by field-ready staff, or people that are, have picked up this idea and are taking it to their local facility to implement. So I think, unless there was other things around those you guys wanted to mention, we can wrap up with the Dream Team Challenge.
Maybe just one quick note on the safety for these kind of lab makerspace tools. It'd be awesome if the submissions came with some sort of risk analysis of what might be some modes of failure and how dangerous is it to the operator.
And if the designs are something that could be shared more, the intention with everything that Field Ready does is that we share all of our designs openly so that anyone can replicate them. We put risk notices on some of our equipment, some of our designs, to say, if this isn't made right and it fails, there could be very severe consequences to life or to health or whatever it might be. So make sure you make it right, and these are the testing steps and all of that. But in that risk analysis, when you're looking at the UV wand or the heat sealer, also think about the health and safety of the makers making it. So, at this step, what you need to be doing is making sure that, you're wearing glasses, because, safety goggles, because you're going to be cutting wire, or, wearing that you're in a well ventilated space because you're going to be melting plastic or whatever.
Yeah, I think that's actually a really perfect segue into the Dream Team Challenge, the discussion of sort of risk assessment and quality control, and again, getting back to the complications and challenges around distributed fabrication and sort of delivery of these tools and devices. So yeah, we're gonna get into the Dream Team Challenge. This is something we put together with Field Ready, with a dream team of 3 engineers, designers, makers, thinkers in mind, who will dedicate 2 months to a sort of engineering sprint to come up with a solution for this. So what we've come up with is we're looking for a means of quality control that remotely tracks and evaluates solutions, protects consumers, and ensures a roadmap for reporting and repair. I think there were sort of a few different anecdotes and case study examples that, you know, again, we'll have listed online, but maybe you guys could share a few of those just to paint the picture a little more.
The inspiration for this challenge, you know, appeared, of course, with some of the very first things that we made. So one of the first things we ever made as an organization were these things, umbilical cord clamps that are to go on the umbilical cord of newborn babies. And this is a 3D printed design. It was developed by one of our co-founders in Haiti, for clinics in Haiti. And it's quite small, as you can probably tell. But, you know, it really is a question of, you know, for us at the time, it was about how do we get our logo on this? Like, so that if more were needed, people know where to go to get it. So they can go to our website, get the design, and make more. Our logo on it, so that if something goes wrong with this, like the clip doesn't work, it doesn't close properly, they can report a fault to us and we'll send them a new one. Or you know, I think as we've grown as an organization and we've developed more and more products, more of these items are being distributed. We share all of our designs openly online, knowing which ones were made by us using our design, knowing which ones were made by other people using our design, and knowing which ones modifications of our design and so on, you know, over time, to make that more of a science and less of an art. If you look at the part of the inspiration is also the future of the maker movement. I mean, the maker movement and maker spaces, they're beginning to inform thinking about what a new kind of manufacturing might be, localized manufacturing, as opposed to the continually sort of centralized and globalized manufacturing that we've had ever since the first industrial revolution. If we're beginning to do distributed manufacturing, the big issue is really about distributed quality control, particularly for some of the devices that we're making that are often safety critical, in low resource settings where perhaps quality control or the expertise isn't there, because they're making lots of different things in a day rather than the same thing over and over and over again, and you get learned experience that way. So it's really about how do we, you know, if in a future where we have massive numbers of small manufacturers making lots of different things every day, what kind of system can we have to have consumer protection so that we can meet some of the standards that have developed in the mainstream manufacturing world? A fairly basic form of consumer protection is knowing who the manufacturer is. And so labeling, ubiquitous, you know, on every mug, on every gadget, not quite on every spare part or internal component, but close. So labeling, serial numbers that allow you to know which production run that came off. Or also you have some kind of, you know, in some cases tracking capabilities, so that you know that a particular batch of distribution went to that location, or even, you know, some tracking potential, you know, in the device itself. So we might imagine, and we've explained some scenarios, we might imagine, you know, myself visiting a refugee camp in northern Iraq and looking at the supplies being handed out to people, looking at, I don't know, this finger brace, a 3D printed finger brace, and trying to work out, if that needs to be replaced, who can I go to replace it? Well, actually, there's the manufacturer detail there. I can track that back to somebody. Trying to work out if it's a field-ready design. It really is a question of accountability and helping to enforce quality assurance. It's so this design challenge is quite a big challenge for us. If there was a simple solution, we'd be doing it already. But so we're doing things like spray painting our logo on the gadgets that we make that are big enough to do that, or we often put we might etch a simple number into it, but then we need the back end system to track that, so that we have some obviously data systems in the organization that allow us to track these sorts of things, but for the purposes of this challenge, assume a blank sheet of paper, and if it's if there are solutions like spray paints or barcodes or serial numbers or QR codes or I don't know, RFID tags, or really have a think about what might work. But you have to think about solutions that could work with small clamps like this, to solutions that might be an entire toilet latrine unit that gets shipped out to a refugee camp. And there's some electronics units, some plastic things, some furniture made out of wood or old pallets or something. What can we do to kind of track each of those and give some accountability for what we make to the people that we're trying to help?
Yeah, and I think that actually that sort of flows right into the next question of some of the skills you think might be needed by applicants to this dream team. You've described a little bit about back-end systems wanting to be integrated and things like that. Again, I know we don't want to put too many constraints on it, but I think definitely the biggest thing I feel like is, an open problem-solving kind of thinker who can really try to wrap their head around this, because it's like you said, sort of a complex challenge with lots of moving parts and needs a dynamic solution that might incorporate some physical hardware or method or process, and some data logging, and maybe some documentation, or maybe it's a magical tool that puts that all into one. So but if there are any skills specifically you wanted to mention that you think would be useful, throw those out there.
Something that I think would be really helpful for at least one team member to have is a background in quality control. Somebody who's worked somewhere and has some familiarity with standards within quality control, I think could give some really good insights into what we might want to incorporate. I don't think that's a mandatory, but I think it could be a really, really powerful thing on the team. I think there could be something interesting with AI here. Maybe not, that might be too high tech, but somebody who maybe has thought about AI. And beyond that, yeah, I think just kind of a Renaissance person, kind of general, a little bit of mechanical, a little bit of electrical, a little bit of software. Yeah.
Luckily, I think there's a lot of those kinds of people in our community. And I think that's a great point about the experience with quality control, quality assurance. And I think that looks a lot of different ways in a lot of different industries. So any sort of standards you're familiar with, sort of at least the gateway into what it takes to set up standards or a process like that. So yeah. I think that's an excellent point. Awesome. I think we pretty much covered a lot of the constraints to this challenge. I don't know if there was anything else you wanted to mention there.
The constraints are that it's this is something we need to be able to use at Field Ready. Field Ready, we work in Fiji, Vanuatu, Philippines, Bangladesh, Nepal, Iraq, Syria, Jordan, Turkey, Kenya, Uganda soon. And we've worked in the US Virgin Islands and Haiti and, you know, Colombia. You know, we're quite international, which means lots of different languages, which means anything that means that we don't have to deal with language might be beneficial. We deal with lots of different types of access, so perhaps not everyone will have a smartphone to use a QR read. Our teams do, but perhaps some of the makers that we would work with, you know, if someone else takes the design for a pipe clamp that we've made, you know, and they produce that, maybe, you know, they'll have a laptop and a 3D printer, but they might not have a smartphone or something. So almost thinking beyond a constraint, sort of removal process of kind of, you know, not just thinking about kind of attaching Field Ready's logo to things, but how would we do this kind of labeling and tracking and quality assurance, customer protection almost within the maker movement generally, where, you know, feedback can go from a user of something that has been made in a local makerspace to the person that made that thing, to the person that originally designed that thing, along that path. Yeah, so it's, I think I would say a constraint is that for if we want lots of organizations to try and adopt this, and Field Ready is in a position to be able to encourage that, to adopt a similar approach to the solution that might come out of this, we have to think about the integrity of that data and how the data is managed, if there is a sort of back-end IT system that manages it all, and recognize that you know, that will need maintenance. ISBN numbers on our, you know, our book has an ISBN number. You know, you can scan that on your phone and it will give you the answer because there's a back-end database that drives that sort of thing. So thinking about some of the maintenance of those systems, whether it would potentially be private information that can reside in your own internal company system, or whether you'd want something much broader that's public. Yeah, there's a lot to play with in this design challenge, and that's why we're looking for a dream team to work on it.
I'm so excited to see sort of, you know, what the Hackaday community is going to bring forth, and just to get these challenges out there and get everyone's input. And super appreciative that you all are dedicating your time to continuing to answer our questions, to put these challenges together. We know that you're very busy, so we appreciate it, and excited to have Catherine on board as a mentor, and Andrew available throughout to ask questions and things. So I'm sure this will inspire even more conversation and questions from the community. So thank you, and excited to get to launch.
Yeah, we're very excited too, and we can, you know, we've been waiting for these things, for these sorts of design challenges, these sorts of opportunities. Basically, it's important to us because whilst design is part of what we do at Field Ready, if we're designing things, if we're trying to solve difficult technical problems, we're not making things. If we're not making things, we're not helping people. So, you know, what this is giving us the opportunity to develop solutions that we can use in the field in lots of different disaster zones the day after that they're ready, and we can try those potentially throughout the design process as we go with our field teams in the maker spaces that they operate, trialing some of these things. But I think it's you know, it wouldn't it be great if the dream team's sort of tracking system could go on to the heat sealers and the UV cure ones, and to the blood warmers, and to the umbilical cord clamps, and to the search and rescue airbags, and to the latrine slabs, and all of the other things that we make, that we would use those tools that people are developing as well to be able to make, so that we can begin to really kind of compete with the mainstream manufacturing way of doing things, to help people who are often at the very, very far end of globalized supply chains.